I can hear pretty much everybody. Okay, and everybody can see my screen.
Yes.
Yes.
All right, perfect. So I'm on the Scratch project basically that we finished off with last week. If everybody did the week 1 training, which I'm pretty sure everybody here did, we should basically have our little Scratch game where Scratch the cat kicks the soccer ball in. No big crazy game or anything, but just a little bit of interaction. Well, today we're actually we're not going to continue off of this game. We're actually going to use the stuff that we learned last week to actually make our first basic simple game. And to do that, we're going to open up a few more of these little script blocks. Namely, we're going to go into operators. We're going to go into the rest of the control blocks to learn some more programming logic. And then we're going to go into the data script blocks to make variables. Okay, so when we're through with today's training, we should have something that looks like this. I call it kitty drop, but basically it's Scratch the cat and some fortune cookies fall down from the sky. I may have shown this last week. As he eats the fortune cookies, once he gets to a certain number, the game speeds up. And if any of them drop and hit the ground, he loses a life down in the bottom corner. So every time he hits 10, the game speeds up a little bit faster and a little bit faster. Make sense?
Mm-hmm.
Yep.
Okay. So the first thing I'm going to do is go into Scratch and just start a brand new project. And I'll call it Kitty Drop 2. And we're going to do a lot of the same stuff that we set up last week, so I'm just going to kind of speed through some of that stuff. If you guys need to stop me for anything, just let me know. But basically, we're going to grab that when flag clicked. We're going to grab our forever loop. And we're going to tell Scratch to go to the mouse pointer. So as of right now, we have our very, very basic Scratch follows the mouse pointer. Okay? Now that's our initial setup for Scratch, the Scratch the cat, that is. Next, we're going to click on the backdrop and choose a backdrop from the library. You don't have to choose the same one that I'm choosing, obviously, but I'm going to choose the same one that I used. Actually, I'm going to choose a different one. I take that back. I'm going to choose a chalkboard. So now when we start our game, the reason I choose backdrops similar to this is just because there's a very definite delineation between the bottom of the screen and the top of the screen. So from a gameplay perspective, the player knows exactly at what point they lose and exactly at which point they successfully catch the cookie or whatever we end up having as the little shape that they have to catch. You don't have to do something like that, but anytime that you can visually help the player understand how the game plays without having to explicitly write out some instructions or something like that, you're basically doing them a huge favor because they can actually learn how to play the game while they're playing. Okay, so now that we have kind of the backdrop set up, we've got Scratch the cat moving around. One of the things that you can see we definitely want to change is in the kitty drop that I just showed you, Scratch doesn't move all over the screen. He just kind of sits on the ground and just moves left and right across the ground. So we need to somehow force him to still follow the mouse but not move up and down. We only want him to move left and right. So does anybody have any ideas on how we can do that?
Set X to 0?
Close. X is left and right.
Ah, set Y.
There you go. So we're going to set X and Y. I'm not going to set it to 0. I'm probably going to set him right around here, 75 or so. I can tell it's 75 because if you look at my stage down here at the bottom, my X and Y coordinates basically say that right about here is Y equals negative 75. Okay? So I'm going to set Y to negative 75, and then I'm going to drag that into my block. Now, something that you want to consider, because again, I've mentioned this several times, but it's so important with Scratch or any programming language that you really want to get used to this. I can't drag the set Y to negative 75 here Okay, I mean, I guess I can. Obviously, I just did. But that's not going to do anything because immediately after, I'm telling Scratch to go to the mouse pointer, which resets the X and Y that we just set. So it's almost as if we did nothing at that point. So I'm just going to pull those out and reorder them so that he goes to the mouse pointer first, and then we reorder, and then we set the Y value to where we want him to go. And you'll notice that right away the stage updated with that new logic, so he's kind of constrained to the bottom area now. So far, so good?
Mm-hmm.
Any questions on this? Okay. So now we need to actually create, much like we did the soccer ball last week, we need to create what Scratch is going to catch. And before we actually go into the game logic itself, we're just going to create the item first. And it's not going to really be interactive or anything, but just like we did with the soccer ball, we're just going to set it up so that it falls from the top of the screen to the bottom of the screen. And then once it hits the bottom of the screen, it disappears. Okay, that'll be our first step to just kind of get this where we want it to go. So I'm going to go create a new sprite. Again, just like I did last week, I want to name Scratch the Cat just so that if we decide to put different types of items that fall from the sky, we can identify them easily. We got Scratch the Cat. And then I'm going to create a new sprite from the library. Now, I chose fortune cookies, but obviously you can choose whatever you want. You can choose these cheesy puffs. You can choose a donut. Maybe I'll change it up this time and do a donut. Let's see what else they got.
Fish.
What's that? Yeah, is there a fish? There you go. We'll have him catch a fish. Okay, so now I've got a new sprite, and it's on the stage. And just like we did with Scratch and with the soccer ball last week, the first thing that I want to set up is some initial conditions that the fish will always reset to no matter what. Okay? And the way that I do that is I go to my events and I choose my when flag clicked block. That basically ensures that every time somebody starts the game, the same stuff is going to happen over and over again. Again, much like the soccer ball, the fish is way too big for Scratch, so I'm going to change the size by using our set size to X block under the looks scripts. So I'm going to try 50% first, and then just double click on it to see if that's about the right size. I think that still might be a little too big. Maybe 35 is, yeah, so 35 is about the size that I want it. So I'm going to reset the size to 35%. Now, here's where our logic comes in. In order for this to actually work like a game and have some kind of level of difficulty, we can't just have the fish drop from the top of the screen to the bottom in the same spot, obviously. So what we're going to do is we're going to first set up the top to bottom, kind of that glide from top to bottom of the screen. And then we're going to set up for that top to bottom glide to start at some random spot on the screen. Okay? So, under the when flag clicked, set size to 35%, what do you think we need to do in order to get the fish to fall from the top of the screen to the bottom of the screen?
Gonna have to set
Go
Y
to.
coordinates.
What's that?
Set Y coordinates and tell it to move.
Okay, so how do we do that? How did we make the soccer ball move last week?
Go to.
Glide, I think we used.
Okay. Yeah, we have a couple options. We can do go to, or we can use glide. Now the difference between the two is that go to happens immediately. So that may work, but it's probably not going to be much in the way of a game because the player's not going to be able to anticipate where that thing is falling. So we're actually going to use the glide block. Okay? I'm going to grab my forever block, just so this repeats over and over and over again. And then I'm going to grab the glide block and see if that works. So I'm going to set the y value to be about the same as what scratch was, so negative 75. Whoops, that's x. Negative 75. Okay. And on the x-axis, it doesn't really matter what we put in here right now because we're going to change that anyway. But as of right now, when our game starts, the fish will drop to negative 75. Now, we also need to put in a start position like we did with the soccer ball and everything, because right now it moves to that position, but now that it's in that position, every time we restart our game, it's not going to move at all because he's already in that spot. So let's reset him when we reset the size. We're going to leave x at 0, but y, we're going to make it go outside of the actual stage area. So you'll notice that the top of the stage is actually at 180, and if you move past the top of the stage, it doesn't continue to grow. It just stays at 180. So 180 is probably the top of our stage. So I'm going to set the y value to 180, and then we're going to run this. So far, so good?
Mm-hmm. When you run, see how it's yellow highlighted? Is that how you get it to just do that?
No, the yellow highlight is telling you what is currently running. So when you hit the reason this is highlighted in yellow is because I have that forever block. I can actually pull that out, and this will technically still do the same thing. And you'll notice that once the game is done running and all those are completed, the yellow disappears. So that's actually a debugging feature, so that if you're having issues trying to figure out like what part of your game is working and isn't working, you can see what's highlighted in yellow to kind of give you an indicator of, hey, this is running right now.
Oh,
so if you're
okay.
having problems with this particular segment of your game, check that out. Make sense? Okay. So now we've got at least the very basics of kind of where our game is going to be. Some things that you might notice that we're having issues with right now is the fish falls kind of fast. We want it to start off slowly. So those are some things we're going to have to fix. Obviously, it's starting at the same spot every single time, so that's another thing that we're going to want to fix. So we'll start by setting an x and a y coordinate, basically, that happens at random. Okay, we'll keep the y coordinate at 180, and actually we might want to even raise this to 190 or 200 so that it starts off the screen rather than on the screen. Okay, so the way that we do that is we have a couple different blocks. If you look at some of our blocks that we have in the different sections, one of the options that we have is under operators. Okay. Operators are basically your standard logic segments for any kind of coding language or any kind of programming language that you have. They basically are kind of the meat and potatoes of all the math that happens in coding. In this case, some of the operator blocks that we have are x plus x, and I say x just because that means we can fill in a value. You can see there's a little space where we can either type a number in or put some kind of value in there. We have subtraction, multiplication, division. We've got random numbers, okay, where I can pick a random number. We've got greater than, or sorry, less than, equal to, and greater than. We've got combination blocks, or what we typically will refer to as AND blocks in coding. This means when we get to our controls, our if and then statements and things where we're comparing two different things, we can compare more than one thing. We've got OR blocks, or either blocks, which allow you to compare if one thing or another is true. We've got the not block, which is basically just the opposite. It's referred to as the not block, but it doesn't quite function as the not block. It's more of it in a little bit more complicated programs, basically just to flip our true and false values backwards. We've got some join blocks, which allow you to join two words or two variables together. So if you wanted to spell out sentences or words and you want to collect the different values independently and then join them together, you can grab specific letters out of a word. So in this case, it will grab the first letter of the word world, or the second letter, or the third letter, or whatever value you put in. If you put in a number and the word is not long enough, or it's a negative number, it will return false. You've got the length of whatever word you have typed in there. And then you've got some special operators. We'll get into these a little bit later, but just for reference, they're called the modulo operator, the rounding operator, and then we have our slightly more advanced math function operators. We're not going to use these for now, but we will use them a little bit later. Okay. So we've seen that we have a random number generator. Basically, we can tell Scratch to pick a random number from whatever to whatever. So if, again, we look at our stage, you can see that the x values of our stage go from negative 240 all the way to 240. Okay, if I go all the way to the left, it goes to negative 240. All the way to the right, it goes to 240. So I'm going to start using those values as my random values. Okay? And now, all I need to do is just drag that random number block into one of the spaces that our numbers go into. Okay? And again, before we play anything, just caveat, we're going to see some issues with this, but we'll fix those issues kind of as we go along. So I'm going to start playing our game, and you'll kind of see what happens with our fish. There are a few small issues that you can probably see right away. Or they may not be issues. You might have a situation where you actually want what's happening to happen. In this case, though, our fish are traveling diagonally sometimes. Now, while that might seem like it's perfectly okay, we're kind of cheating the player if the fish are moving diagonally, because then they don't really know where to expect the fish to go to. So it's kind of unfair. So here's where we're going to use our first variable. And if you're not familiar with variables, if you've never done any programming, a variable is just a way to store some kind of number or value so that you can use that same number or value multiple times. Okay? Obviously, if we're using a random number generator, every single time we use that random number generator, it could potentially give us a completely different random number. So rather than going to a random x value and then gliding to a random x value, we're going to go to our data section and we're going to create a variable. Okay? There's a button that says make a variable. And when we make a variable, there's a few things that we need to decide. Number one, we need to decide a name. So I'm just going to name this variable fishyx. You can name it whatever you want, but it helps to be descriptive, obviously, so that when you're looking through your list of variables, if you have multiples, you can pick out the one that you want. And then we also have to choose a for all sprites or for this sprite only option. Now, what that option does, you can probably figure it out already on your own, but I'll just explain it really quick. For all sprites means that every item or every sprite, every part of our game has access to that variable. Okay? Even though we've saved a number into our variable or we've saved something to a variable, we can still make changes to that variable if we need to. Okay? This is basically just asking, what do you want to allow those changes? Okay? Do you want any item on the screen to be able to change that value, or do you just want this particular sprite to be able to change its own value? Okay? In this case, because it's the value that we're putting together, the x coordinate of the fish, is specifically applicable to the fish, we want it to be for this sprite only. We don't really want anything else to change that value. Now, later on, we will use some of these global or for all Sprite variables for things like the score or the number of lives the player has, because obviously the score goes up as we catch fish, and it goes down if they drop onto the level. So we need multiple things to be able to access that. So now a couple things happen. The first thing that shows up is we actually get a listing of our variable with a checkbox next to it. And the checkbox just controls whether or not we see that variable on the stage. So as I turn it on and off, you'll notice in the upper left-hand corner of our stage, that variable disappears or appears, depending on if it's checked or not. This is just useful for when we're testing our game or actually building it, that we can see what the values actually are. And later on, we may want to actually use this for certain things like the score. It's really helpful to be able to display the score here instead of having to manually plan out all the numbers and all the different combinations of things. So for right now, I'm going to leave that checked on because I need to know what the X value of my fish is, just so I can make sure everything's working properly. Then we get some options or some blocks, some script blocks specifically for this variable. For one, we can set a variable to a specific number. We can change a variable by a specific number. We can show a variable, and we can hide a variable. So show and hide are basically the same thing as doing this, checking the box on and off, except we can do it programmatically. So we don't actually have to click the box or do it or whatever. So technically we could set up like a little flag that says if we're in testing mode, show the high score or show the X coordinate. If we're in regular play mode, then don't show it. We're not going to do that. We're just going to control it manually for now. So the first thing we need to do is we need to set up what our X coordinate is for the fish. So I'm going to grab this first block, set fish X to 0, and I'm going to put it right after our size option, because we want this to be set every single time the game starts. We want this value to be set. Okay? And I'm actually going to grab our pick random number block and just move it up one space. So I'm going to take the block we were already using to figure out our random number, and I'm just going to drop it into that set. So now what we're saying is, when we start the game, set the size of the fish to 35%, and then basically pick a random value for the fish's X position. Okay? And now, once this step is set up, we can actually take this fishy X block and fill it in for any of the spots that we want that number to be used. Okay? And because we've set a variable to that number, it will use the same value every time. So now we know for certain that our fish is going to start at one X value and then glide to that same X value, and only the Y position will change. And I'm going to drag our other random block back into the script section to delete it. So now if we start our game, every time we start, our fish should start in a random spot from -240 to 240, and it should go in a straight line. So far, so good?
Mm-hmm.
Does anybody have any questions on this? Or on anything we've covered up to this point? Good? Okay, so now, another issue that you may have seen, I've been clicking this now for a couple minutes, and I think I've only seen the issue pop up twice. But another issue that you may run into is that Scratch sets these coordinate values based on the center of whatever the object is or the sprite is that you're talking about. So at least a couple times, just by virtue of random numbers, what might happen is that the fish might actually start off screen a little bit because the center of the fish might be at -240 or +240, but the beginning or end of the fish is actually a little bit bigger or a little bit less than that. So I'm actually just going to check our random number values, and I'm just going to resize them so that it's not quite as high as it was initially. So instead of negative 240 and positive 240, I'm going to bring those in a little bit to negative 220 and 220.
And that's the value of using go to FishyX and being able to move that same little guy, because if I change it up there, it's going to change it every time I see FishyX.
You got it. You got it. That variable is saved everywhere and doesn't change at all unless some other value or some other item changes it. And again, because we set the fish to be the only one to change it, if I try to go to Scratch and make something that tries to change that value, I can't, because you'll notice in my data section there is no FishyX variable. Scratch can't change that value. Our stage can't change that value. The only time we'll see that value, that variable, is if we have the fishy selected. Does that make sense? Okay, so now we're starting to get the basics of at least the movement of our game. Now we actually want to set what happens if the player is successful or not successful in catching the fish. Okay, so when we first started setting this up, we set it up so that the fish went to the same value as Scratch the Cat, which was that negative 75. But if Scratch the Cat doesn't catch the fish, we should probably have it hit the floor. So I'm actually going to do the same thing that we did for the random numbers. I'm going to just make that value a little bit higher so that if Scratch the Cat doesn't catch the fish, it actually goes a little bit farther down and hits the floor. Okay? Maybe even a little higher than that. So basically what I'm doing here is I'm trying to find a value that makes it fair for the player so that the player knows, hey, you missed the fish. It's obviously touching the floor, it's on the floor, but I don't want it so far down on the screen that the player is easily just going to be able to move the mouse, you know, back and forth really fast and basically catch every fish. When it comes down to a game like this where a lot of stuff is dropping at the same time, we're literally coming down to seconds between the player catching the fish and not. So we want to make it fair, but we don't want to make it too easy either. So I think that's a good value right there, negative 130. The fish is fully on the floor section of the backdrop, but it's just barely there so that it counts. Okay, so now let's set our conditions and our logic for both the player catching the fish and the player not catching the fish. Okay? So in order to do that, we're going to need some if blocks for sure, and maybe some if-else blocks. And as we saw last week, and now we'll get into a little bit further, these are just basically blocks that help you make decisions in your game. Just like they're named and just like it sounds, we're basically saying if something happens, do this. Or in the case of the if-then-else blocks, if something happens, do this. Otherwise, if that didn't happen, do something else. Okay? So in this case, our very first item is we just want to detect if Scratch caught the fish. And if he did, we want the fish to disappear, because right now if he catches the fish, it's still kind of on top of him and it makes it all the way down to the bottom of the ground. Okay. So what we're going to do is we're going to start off by making an if-else block. I'm not going to connect it to my fish block yet because I want to make sure that my logic actually makes sense before I do anything. But I'm going to need a condition and then a result for that condition. So what do you guys think we need to do in order to detect if Scratch actually got the fish?
Use the touching from sensing.
Okay. So same block that we used last week for the soccer ball is touching, and we have the ability to detect if Scratch is touching, or that sprite is touching the mouse pointer, the edge of the screen, or if it's touching Scratch the Cat. So if we put that little gem block in there, we now have a block that says if Scratch, or if the fish is touching Scratch the Cat, then do this. And what do we want it to do?
Hide.
We got to hide. Anybody else got any suggestions or options? Hang on, Melody, you're muted.
Oh,
Yeah.
that's okay.
Hide is probably the one that I would use too. There's a couple different things that you could make it do. You could change the fish's costume if you wanted to. Some people like to, change it to like a eaten fish, or to when I did the fortune cookie one initially, the first one that I did, it turned into an actual fortune, so it was like a little slip of paper. So, but we're just going to hide it for now. We can always customize this and make this a little bit more polished later on. But for now, we'll just hide it. And we'll connect that to our block. Okay. And what's going on? You should see some issues already.
Is that because Forever's not in there?
That's one issue, yes. So one issue is that it's not, just like with the soccer ball issue that we had last week, it's not always checking if Scratch the Cat is touching the cookie. It only checks immediately when we click the flag, and that's it. So we're put that forever block in there, and basically the fish is going to glide, and Scratch the Cat is always going to check if it's touching the fish. Okay, still not going to be perfect, but we'll see something happen. So what else is the issue now?
You should probably put a show under when flag clicked.
Exactly. Anytime we're hiding something on the screen, we need to make sure that when our game restarts, we're popping it back up. Otherwise, you'll never see it again. So I'm actually going to put the show block. Whoops, didn't mean to snap it there. I'm going to put it after we set the size of the block. And the reason I'm putting it after is, again, just because of the order of operations that Scratch is going through. We might see it pop a little bit if we put it in that order. It is happening really, really quickly in that order, so it may seem like it's happening all at the same time. But we just want to make sure that that size changes. Okay, so what's happening now?
They're disappearing when it
Even
hits
if you
the
don't
floor.
get it.
Okay, it's not disappearing until it hits the floor.
Right.
Okay, and again, same type of thing. Because Scratch is doing exactly what we tell it to, it's going through these steps first before it ever checks if it's touching Scratch the Cat. Okay, so we need to change this so that instead of gliding first and then doing the check, it's actually gliding while we're doing our check. Okay, I just want to point out that this glide block, we may end up changing this kind of as we go through our game. As of right now, the glide block still starts at whatever the position the fish is currently in, so it will work for what we're trying to do, or at least it should work for what we're trying to do. Maybe not. Okay, so then we're going to need to replace this with an if-else block. We're going to make the exact same type of block that we did, but now if it's not touching Scratch the Cat, then we want it to keep gliding. Does that make sense?
Mm-hmm.
Okay. One of the things you might notice as we kind of continue this, as we make this more complicated, the reason that the glide block is not perfect is because you can't really change speed except for setting up the number of seconds that it takes to actually glide. So one of the issues that we might run into is that this glide block might actually do that motion and then stop right here. Does that make sense? Yeah, so that's exactly what's happening here. So even though it seems like our logic should work, that glide block is throwing this off because Scratch is running through these steps in order, and then when it's getting to the glide block, it's waiting until it finishes what it's doing. So it's basically not going back into our forever loop here. until this finishes. Okay, so here's where we need to create another variable. And we're actually going to update this variable regularly. And basically, we're almost doing what the glide block does and just kind of separating it out into the individual steps. Okay, so what we're basically saying is, if Scratch the Cat is touching the fish, then hide it. Otherwise, move the fish down the screen a little bit. Okay, so we're going to do that in our motion block, and we're going to change the Y value. Okay, we've already got our X value set, but we're going to change the Y value by 10. Okay, actually, we should probably do -10. We want it to go down, not up. Does that make sense? So essentially, we're kind of doing what our glide block was doing. It was moving the Y position of the fish, but we're only moving it if Scratch is not touching the fish. Okay. Now, something you may have noticed, we set our -130 up here on the glide block so that the fish stopped at the -130 mark. So we also want to check to make sure that the fish stops at the 130 mark. Okay, so what we're going to do is take another if block and drag it in here, and we only want this negative Y change value to happen if the Y value of the fish isn't already past -130. Does that make sense? So we're going to go back into our operators, and here's where our greater than and less than blocks come up. Basically, since we're going to negative values, we want to check if the Y position of the fish is less than -130. Okay? Actually, sorry, if it's greater than. Because if it's less than, then we want it to stop, not keep going. So we're going to put this in here. If blank is greater than 130, then change -130. Hello, there we go. If it's greater than -130, then change it by -10. Okay. We could create another variable like we did for the fish's X position, and we can definitely save some kind of position for the Y coordinate. But we don't really have to, because Scratch actually gives us, under the motion section, the current Y position or the current X position of that sprite. So basically now what I'm saying is, if Scratch the Cat is touching the fish, otherwise, as long as it's not below the area that we designated, that -130, change the Y position by -10. Does that make sense? Okay, what questions do you guys have on this right now? Everybody's good? Okay, so far, we kind of have our little game working pretty much how we want it to work. But we don't want the player to be able to collect the fish that fall on the ground. Okay. So, how do we determine if the fish has hit the ground yet or not? Anybody have any ideas?
If Y equals -130.
Okay, if Y equals -130. So we basically told this, if the Y position is greater than 130, which was the spot that we wanted it to hit on the floor, to keep changing the Y value. Okay? So we're going to take another control block, and once that happens, we just want to check every single time if the Y position equals negative 130. If it does, let's do the same thing that we did if Scratch the Cat is touching it, and for right now, we'll just hide it. Does this make sense? Okay, so what we're saying is, if the Y position is greater than negative 30, keep moving the fish. If not, then hide the fish. Okay, we could also combine these two. Notice how we've got an if followed by an if. In the case where we only really want one of these to fire sometimes, we can replace that with an if-else block. So we can say if the Y position is greater than negative 130, change it. Otherwise, just hide him. Okay. I did it this way, though, to show you one quick point. Okay. You'll notice I'm hitting the flag, and the fish isn't disappearing. Whoop. He hit Scratch that time. That's not fair. How come this isn't working? Anybody have any ideas? No one? Okay, I'll give up the game. We basically told Scratch that if the Y position of our fish is greater than negative 130, to change his position by 10 pixels down. Okay? The very first time that this statement is false is at negative 131. Okay? Or actually at 130, but it's also true at negative 131, 132, 133, negative 135, all the way down. So if for whatever reason the fish's position doesn't equal exactly 130, this will never fire. This will never happen unless that position is equal to 130. Okay? But we're moving Scratch by 10 pixels at a time. So it's very possible that while Scratch is running and doing its little loop over and over and over again, that the fish is actually stopping at negative 135 or 136 or any one of those values. We're basically it's kind of a crapshoot. Just once the game goes frame by frame through everything, we can't tell for sure that it's stopping at negative 130 unless we manually set that 130. So rather than having Y position equal, we want to use greater than, or as I mentioned before, and that's what I'm going to change it to, I'm going to use an if-else block. So if the position is greater than negative 130, keep changing that value. Otherwise, if it's less than negative 130, which is the only situation, so basically the opposite of greater than is less than or equal to. Those are both situations where it would work. And now our fish disappears every time. Does that make sense why that didn't work? Does anybody have any questions on why that didn't work or why we needed to fix that? Or more importantly, how we fixed that?
I'm following along with your example in Scratch, and for some reason mine isn't hiding when it does hit that value. Like, for example, I'm using negative 200 so that the sprite goes all the way out of the screen. Is that too high of a value, or is there something else going on?
Well, So as we saw before, like if you go and move your mouse pointer outside the edge of the screen, it stops at -240. So you would need to stop it at where the Y value stops. So it would need to be 180. Or like we did with the left and right sides, you need to kind of allow for some room. So I would go greater than 80.
Okay, I changed the value and that worked. Thank you.
Yeah, and if at any point, I forgot to mention, if at any point you guys want me to kind of look in on what you're doing, on the left-hand side of the Hangout window, if you move your mouse, you'll see a bunch of icons on the left-hand side. There's one with a green computer screen with a white arrow on it. You can actually share your screen so I can see what you guys are doing if you want me to kind of look in and just give you some feedback. Okay, so moving right along. So now we kind of have the basics of our game. Our fish drop. If Scratch catches them, they disappear. If they hit the floor, they disappear. Everybody good so far? Okay, now we can actually add some interactivity to this and actually turn it into a game. Okay. And what we're going to do, and we'll be running out of time soon, so if anybody has to jet, this can kind of be your homework. But we're going to use the same type of logic that we have here, where we determine if Scratch the Cat is touching the fish or not. We're going to create some variables that keep track of how many fish he's caught and then how many lives he has. So what I'm going to do is I'm going to click on our backdrop, our stage here. I'm going to go to the data section, and I'm going to make two variables, one for the score, and I'm going to make another one called lives. Okay. You'll notice that if you make variables on the backdrop, it doesn't have a local or a this sprite only option. That's because since the backdrop is actually our level, anything can make adjustments to this. Okay. So now I've got two variables. I've got lives and I've got score. Okay. And the first thing I want to do is make sure that every time our game starts, our score resets to 0 and our lives reset to however many lives we want. In this case, I'm going to pull up our flag. And since Scratch is a cat, I'm going to give him 9 lives. And my score is 0. Okay, so now every time the game starts on our backdrop, we set our lives to 9 and our score to 0. Okay? Now, when you're doing things like points and lives and scores and things like that, there's always, and this will happen a lot in coding and programming, there's always, pardon the pun, more than one way to skin a cat. There's always more than one way to do lots of these different things. In this case, we could check to increment the score by whether or not Scratch is touching the fish, or we could just have the fish use our existing code and say, you know, if it's touching Scratch, then let's bump up the score by 1 point. Since we already made this little segment, I'm just going to do that because it's probably the easiest way to go. So if Scratch the Cat is touching our fish, then change the score by 1. Otherwise, if the fish disappears, change our lives by -1. Does that make sense? So now if we kind of play our game...
The lives.
Is it supposed to say change fishy X to -1?
Oh, sorry. Whoops. Nope. You're absolutely right. Lives.
Oh, okay. Okay. I just was like, whoa, what are we doing with fishy X? Okay.
No, you're absolutely right. And right away you'll see an issue. If you're staring at my screen, you'll see the issue come up pretty quickly.
It just keeps subtracting 1.
Yeah, it just keeps going and going and going. Now, what's weird, or not necessarily weird, but what you might notice is that that doesn't happen if Scratch catches the fish. Like, it doesn't happen to the score. Even though our logic is kind of the same, the big difference is what actually triggers this value. So what we're actually doing is asking if it's touching Scratch the cat, then change the score. But if not, either change the Y position or hide it if it's hit the floor. And again, that fish basically will change the lives by -1 hide, and then when it redoes this loop, it's still not touching Scratch the cat because now it's hidden, and it's still greater than, or sorry, less than 130. So it's basically redoing this else loop over and 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 over again. Okay? So we need to change this a little bit. Let's see if that works. I don't think that'll work. Yeah, that's still broken. Okay, we got to figure out a way to stop that from continually doing that. Let's try another event. This is actually not going to be an issue when we move on to the next step, because we can actually kill that sprite, but for right now we're not going to do that. Where is my if hidden? Sorry, I'm looking for a block.
I think I figured out a way to do it.
Sure,
Possibly.
go for it. Go for it.
Okay, I'm gonna try sharing my screen.
Okay.
Okay.
If you guys decide to play around with this kind of in afterwards as like a homework assignment for next week, we're actually going to be using these clone features down at the bottom, and the one that we would use right here is delete this clone, because then it just pulls it out of the level. Okay, let's see what you got on your screen.
All right, can you guys see this?
Yep.
Okay, so when you hit the flag, it falls. When it hits the ground, it changes the score by -1, and then it stops.
Perfect.
And I did that by adding an if-then, using the Y position, and I actually did -159 because, like we saw earlier, if you do 160, it'll never trigger. And then I just changed the score by -1 and then did stop.
Perfect. And actually, with the stop block too, a good kind of thing to note is that we can actually, instead of stop all stops the entire game, we can actually just stop this script from running. So that way we're not stopping the entire game, because obviously we'll want to continue the game, but you'll notice that the lives go down. And actually we probably want to add that stop block also to if he's touching it, so that way it doesn't keep falling. Because otherwise we're going to lose a life and do that. Does that make sense? Is everybody still following along?
Yeah.
So basically what our script says now is, once the game starts, we're going to set all of our sizes, we're going to show the fish, we're going to set our coordinates and everything, set to where it's going, and then if it's touching Scratch, update the score, hide the fish, and stop the fish from doing anything else. Okay? Otherwise, if the position is still above the ground, lower it by 10 pixels. Otherwise, if it is on the ground, hide it, subtract a life, and then stop the fish script. Okay? All right, so we're pretty much done with kind of the basics of our game. Obviously, it's pretty quick because we only catch one fish and then it's over. So what I want you guys to do for next week, if you can, and again, I'll be in the Slack channel answering any questions if you have them. But what I want you to do is look up these clone options that are at the bottom. Sorry, let me get my screen back up there. These clone options that are at the bottom of the control block. Okay. And what clone is going to do is it literally takes whatever we have done on the current sprite, and just like it sounds, it makes a copy of it. And the reason we're going to use these next week is we're going to have the game create multiple fish, like you saw in my example. There's multiple fortune cookies that fall, but we're not going to have different logic for these fish or fortune cookies or whatever for every single one. It's the same logic, the same behavior, same everything for every single one. So rather than creating and adding a bunch of sprites to our sprite palette here, we're just going to clone them. So for next week, look up, we're actually going to go over how to do it, but feel free to look up kind of how that works and extend your game, and then we'll cover it and see what you guys came up with and then what is another possible solution on my end.
Okay.
Sound good?
Sounds good.
Okay, and you said, you guys all said 1:30 Wednesday is best for you guys next week too?
Yes.
Okay, awesome. Before I let you go, does anybody else have any other questions about what we covered here, about what we're going to do next week, about the Spark program, or anything else?
No.
No? Okay, like I said, I will be in the Slack channel if you do have any questions as you're working through this. If you need anything else, you can always email me or just hit me up on Slack.
Okay,
All right,
thank you.
Awesome. Thank
Thanks,
you.
guys. Have a good day. See you next week.
You
All right,
too.
bye.
Bye-bye.
Bye-bye.